All right, I guess we're going to go ahead and get started. Good morning, everyone. My name is Sarah. I'm the Global Youth Citizenship Representative Intern with the Global Youth Advancement Network at Michigan State University, and I will be moderating this event. So I want to welcome you all to the GARD Innovation Challenge Winners Roundtable. In today's event, the winners of last year's Innovation Challenge will present a brief overview of their projects, share their experiences from the challenge and their new achievements from over the past year, and also give some strategies and tips for successful innovation. The Global Alliance for Rapid Diagnostics, also known as GARD, conducts innovation challenges during its annual forum to promote interdisciplinary collaboration and foster ingenuity in solving relevant global problems to improve human life and welfare. Last year, participants of the Innovation Challenge chose one challenge prompt and created a 3-minute pitch video on their proposed solution. We received 42 submissions from 5 countries, and today we welcome our winners. So we will begin by introducing the founder of GARD, Dr. Evangeline Alusilha, who will give her welcome remarks. Dr. Alusilha is a professor in the Department of Biosystems and Agricultural Engineering, a fellow of the American Association for the Advancement of Science, and a member of the National Academy of Inventors. I'll hand it over to you, Dr. Alusilha.
Thank you. Good morning. Thank you, Sarah, for our generous introduction. And good morning to everybody. Good afternoon or good evening, wherever you are. Hello, as Sarah said, I'm Evangeline Alusilha, and it's my privilege and great pleasure to welcome all participants in this Innovation Challenge Winners Roundtable. This is the first event of this kind, and so we appreciate and congratulate the planning committee, Luna, Leticia, James, and now Sarah. Thank you for being part of this team. Thank you, everyone. Now, to the winners, congratulations again. We acknowledge your outstanding contributions to last year's GARD Innovation Challenge, and we hope that you will continue your quest to solve societal problems of global importance. I invite everybody here to register for the 2024 Innovation Challenge. I just want to give a pitch on that one. On behalf of GARD, we also express our gratitude to the judges last year, and Dr. Opal Bartzis is here. We appreciate your time and commitment and help. I also would like to acknowledge Mr. John Chamberlain, Mr. Kenshas Moshak, and Dr. Edward Walker as part of the judges last year. They contributed a lot of their time to make it successful. And also, I want to just remind everybody GARD's vision. GARD is a community of innovators, and our vision is to prevent illness, save lives, and improve quality of life through rapid diagnostics. Our mission is to develop technologies that are affordable and accessible, especially to communities that help need the most but can afford the least. For GARD, we support sustainable health, which includes the human body and everything else that maintains it: safe food, nutritious food, clean water, and clean environment. So without much further ado, I welcome everyone and initiate this roundtable webinar. I'm excited about the event. So back to you, Sarah.
Thank you, Dr. Alusilha. So now I would like to invite the winners to give a brief summary of their winning projects. So last year we had 3 winners, and today we have 2 of those winning groups joining us. Dr. Munir Adnane from the University of Tiaret in Algeria, and Seema Livuwani and Dr. Moholisa Ennett from the Agricultural Research Council in South Africa. Dr. Adnane, would you like to start by sharing a brief summary of your project and any of your achievements over the past year?
Thank you so much. Thank you for the invitation. So it's my pleasure to join you again. So I'm showing my presentation. So my project was about developing a cow-side screening device for the detection and prediction of uterine disease in cows. And we we are interested in the uterine disease because it's considered as one of the most important and cause of infertility in the farming industry, so especially the dairy industry. And the problem is that even after the treatment of the disease, the fertility remains lower than the normal, and we will have high number of cows with irreversible fertility. Infertility. That's why the cost of the disease is around $300 per cow per year. So in the US, the incidence is around 32%, and taking in consideration the herd size in the US, which is around 95 million between beef and dairy cows. So the cost of the uterine disease will be around $29 billion a year. So it's something interesting. And the problem is that all the available technique for the diagnosis of the disease are based on the clinical detection between 21 and 60 days after calving. So the problem is by this time, we already have some substantial damage to the animal health, and the fertility is already compromised. So it's too late to make the diagnosis. Sorry. So the aim is we want to develop the side that can be used on the farm, on the field, and by measuring inflammatory biomarkers. So this will help rapid and accurate prediction of cows that will develop the disease before the onset of the clinical symptoms. So we can predict, not diagnose the disease. And this will help farmers to save time and money, and will improve the management of the dairy herds. So the solution we want to bring is by developing a non-invasive technique, because we have some techniques, but they are really invasive. For example, the biopsy, which probably would affect the tissue integrity in the genital tract and will trigger inflammation. So the technique we want to develop is non-invasive and is based on the measurement of immune active molecules, inflammatory biomarkers, at day 7, before the development of clinical symptom. And this idea was developed based on previously published results, where we found that there is a significant gene alteration in the genital tract at day 7. That's why we think about day 7. And as initial result, we found by measuring different and several biomarkers, we found some of them, for example, AL1 and AGP. AL1 is a cytokine, AGP is an acute phase protein. So these biomarkers could be used as predictors for the uterine disease. And the critical novel aspect about the technique we want to develop is the way how we process the samples we want to analyze. So we want to measure and detect cause based on the analysis of the cervicovaginal mucus. But the problem with the cervicovaginal mucus is the high viscosity. So it was not possible to run molecular biology tests with the mucus. We developed a technique to process the mucus and make it suitable for molecular analysis. So as you see in orange graphs, this is a technique we developed, and in blue, the reference are the GARD standard in literature. So the technique we developed can generate higher reading. So it means that can detect more with high power the molecules we want to measure. So this could be considered as a proof of concept for the developing early diagnostic device that could improve the management of uterine disease. So it could reduce the cost of the uterine disease in the dairy and beef cattle. As target market, we want to develop the test to be used by farmers and by the vets, because the idea is developing practical on-field diagnostic tests that can be used on the farmers. We don't need to go to the lab to run the test and to wait days or two to get the results. So it will provide immediate results by colorimetric change, the same thing as we used for the pregnancy test in women. So this will ensure administration of the best treatment at the right time and can reduce the impact of the disease. So the idea is develop an expensive test that can be used by all farmers in all cows, or at least at-risk cows. As market size, so there is high profit in this field, because they expect several $1 million income in the US market alone, with a great potential internationally. And the good thing is that there is currently no available curbside screening device, so there is no kind of competition in the market, and all the diagnostic techniques are based on clinical exam by the vets. But as I said, this is too late because it's between 21 and 60 days, and by this time the fertility is already compromised. And also it's not really sensitive because it cannot detect the subclinical form where there is no clinical symptoms. That's why we go to the paraclinical test. In this case, we use, for example, the leukocyte esterase test strip in the urine. But again, this is not really specific and can get positive result in any infection in the organism. It's not really specific to the genital tract. So the test we want to develop can identify by measuring specific biomarkers that can reflect accurately the uterine environment at day 7 before the development of clinical symptoms. So we expect the cost of the test will be around $10 per cow. So by detecting and diagnosing the at-risk cows, the farmer could save around $86,000 a year. And in the US, with the herd size with around 95 million beef and dairy cows, we expect an uptake of our test by 35%. So the potential financial realization in the US market will be around $350 million a year. But also there is an interesting international commercial potential in many countries, especially in New Zealand, Netherlands, Ireland, and France. So we think that this test will help in increasing the competitiveness of the US farmers, so all of which will increase the profitability of the national meat and the dairy industry. So this is the presentation or the overview about the concept of the project. And as achievements, taking in consideration the comments of the judge the last time, we go further and we develop a concept for this test. And also I have to remind you that all the technique available that require high technicity. So we need to make people learn the technique, and it's hard to do. Also, it requires expensive equipment. And the most important thing, they are not possible to apply on the field. That's why we came up with a solution to develop a lateral flow assay, LFI, which could predict the disease, and at the same time, it's not invasive and can provide rapid detection of the disease. It's user-friendly, so it doesn't require technicity. It's with high robustness, and it doesn't require complicated equipment, so it's easy to do, and with high sensitivity and specificity, and can use a low volume of sample to run the test, and it's really accurate for reflecting the uterine environment. So we want to develop a multiplex lateral flow assay. So this strip test can detect 2 markers at the same time, AL1 and AGP, cytokine acute phase protein, on the same test strip. And also we want to use to label the antibodies to change the color and to make it easy to read for the farmers. We want to use colloidal nanoparticles for 3 reasons. First of all, it's easy to produce on the lab, so we can synthesize them in the lab, and they are biocompatible, so we can conjugate them to any antibody. But the good and amazing thing about the colloidal nanoparticles is they can be saved and stored in farm conditions, so it doesn't require refrigeration or any other sophisticated conditions. So the 3 steps of developing this test is by synthesizing these nanoparticles. Then we have to find common antibodies against AL1 and AGP. Then we conjugate the nanoparticles to the common antibodies. This is a schematic representation for the test we want to develop. And so it's mainly produced with this baking card, and we will have this sample part where we put our samples to analyze, so this vaginal mucus. Then we will have the conjugated part where we put the nanoparticles conjugated to the antibodies. Then we will have 3 lines, 1 against AL1, 1 against AGP, and this quality control test. and this absorbent part will absorb all the excess of the sample. So all this will be made of natural cellulose membrane, and the three lines will be immobilized with the first one with antibodies against AL1. This is the first line. The second line is antibodies against SGP, and this one will be the quality control to confirm that the test is working well, and we can take in consideration these results. So we will use the technique, the isoflow dispenser, to project the antibodies on the three lines, then we dry them. And this is an important step. We need to block all the unsaturated receptors in the natural cellulose membrane to increase the accuracy of the test. And then we just dry them and go to the next step, where we produce the conjugate part, where we put our conjugated antibody with the colloidal nanoparticles. So this is the conjugate part, and then we will just dry them and store them to be used later. And by using the test, we need to compare them with a reference, which is the gold standard, in this case, the ELISA. So we need to compare the results to validate if the test is performing very well, if it's accurately detecting the AL1 and AGP. So we will compare the result with ELISA. Also, we need to confirm that the test is really and accurately predicting the disease, the uterine disease, and we will compare the results with the gold standard, which is the uterine cytology after day 21. And finally, what we really need is to collaborate with people with a know-how and technology in making the LFI. So this will help in finding the best antibodies to be used in the test strip, and also determine the accurate concentration of each antibody. And finally, we have just to determine the exact amount of sample we need to use to run the test. So this is the general idea about what we have done and what we want to do on the next step, and which people we need to collaborate with. Thank you.
Thank you so much. I would now turn it over to Seema. Would you like to introduce your project and share your achievements over the past year?
So in the past year, we successfully led a new product development project focused on the utilization of slaughterhouse byproduct, which is blood, to turn it into blood sausages. We navigated the challenges of creating a unique and high quality product in the food industry. Our team meticulously researched and tested various recipes, ensuring a blend of flavors that stood out in the market. We had analysis such as the sensory evaluations and also the purchase intent to check the likability of the new product in the market, and also in the likability of our consumers, our targeted consumers. We overcame production challenges, also established efficient supply chains, and we successfully had positive consumer feedback, and we are also in the way of launching our product, and also we are also about to publish scientific papers of our new product development. Thank you very much.
Thank you, Seema. I see that Dr. Mohalisa Ennett was able to connect. So would you like to share about your project, your achievements over the past year, and any areas of development you are continuing to work on?
Oh, all right. Thank you very much. Our innovation challenge was to use blood sausages in South Africa to combat the food insecurity, because there is high food insecurity in South Africa, and South Africa slaughter a lot of cattle, a lot of livestock, from sheep to pigs, but the blood is just going down the drain. It is not used. And if you look at other countries, mostly in the European countries, you find that these blood sausages are well known, and they come in different names depending on the country of origin. more especially in Europe, even Southern America. The Asian countries also have the blood sausages. But in South Africa, although we slaughter a lot, the abattoirs that have technology to process the blood, they only process it into animal feed and also to use it for as fertilizer for plants. So the other thing is some of the abattoirs, most of the abattoirs do not have the technology to collect the blood. So with that thing causes environmental damage and a lot of pollution, which causes some of the illnesses. So what we thought was like, because we know in our rural areas in South Africa, in the past, the people, when there are traditional celebrations, especially the women, when the animals are slaughtered, they will go and collect the blood. They cooked it without adding any value to the blood. So we thought, like, because in other countries, there's a product called blood sausage. So let's try to optimize this cooked animal blood and make it into a sausage, because we eat a lot of sausages in South Africa, and see if the people like it. So that is what we did. So in the past year, after the competition, we did a lot of product development. We did product development thing, changing from one product to another. We did our testing and validation, where we did laboratory analysis. We did physical, microbiological, and also chemical analysis. And we also did the consumer tasting panels. But before the competition, we did some of the products, and we did consumer acceptance test only, where we wanted to see whether the people will tell us whether they like the product or they don't like it. That is what we did before the competition. Then after the competition, with improvement in the recipe, we did what we call descriptive sensory analysis, where we train people to be able to describe our products. So that is what we did in the past year. And then apart from that, what we did was a lot of exhibitions. We took our products to exhibitions. We took it to farmers' days, and just to find out from to find out reactions in the public space. So yeah, that is what we did. And the other thing is we did the outcome from in the past year was, we also did like the information dissemination, where we attended the conferences. One conference was international conference that we did in Italy, where we presented a poster, and the other one we did locally, where we also presented a poster. And so yeah, those are, I'm saying, I can say there are significant outcomes from us. Also, like, to interact with the consumers, I'll say it's a significant contribution, significant output, because we have the data that we are still working on to see how is our product, how does it look like, do they like it, they don't like it, how do they describe it. So now the steps that we are working on, because our aim was like at the end we get to commercialization of the product, but the biggest problem we have is the technology to collect the blood, to hygienically collect the blood, because with our recipes here, we had old equipment that we ended up not using it because it was so difficult to use it. We did the open collection, but bearing in mind that we don't contaminate the blood. So what we are now working on, like, I'm certain that with the product, I now know the ins and out of the product. Maybe it's just a matter of upscaling and going to the market, because we haven't done the market test, we haven't done commercialization, and also in the future, if we manage everything, we can even do the post-launch evaluation. So if we can get that technology, because now the other thing that I'm really working hard on is to apply for funding to get the technology installed for us, because in our institution we have this experimental abattoir. It's the same thing with the experimental abattoir. The blood goes down the drain, which you don't want. You want to save that blood to convert it into food production. Yeah, because the other thing that besides this, the using the whole blood, we can even use the blood and turn it into edible proteins such as plasma, because those are some of the proteins that we can get from blood and are used a lot in the food industry. So because of the technology, that is where we have a bit of a problem. Yeah, that is all I can say about our product or our developments with the product up to this far.
Thank you so much for sharing that. And thank you also for sharing about some of the challenges you faced and how you've had to pivot to try and figure out ways to get around those. Dr. Adnane, I wonder if there's been any challenges for you in your work that you would like to share about, or any major lessons, maybe the one or two lessons that you've had to learn over the past year.
Thank you, Sarah. So far, I'm just in the step of optimizing, or probably I would say designing the theoretically the test. So I haven't yet gone to the experimental and trying to work on that. So I'm just working on the design and trying to find the best antibodies so far. But yeah, it's really challenging to find. Sometimes when we work with antibodies to find common antibodies, it's really challenging, and to make things cost effective and expensive, we need to think about cheap producing antibodies, cheap labels that can be used for labeling antibodies. So yeah, probably I haven't gone yet to the experimental field, and I don't know exactly what I will be facing as challenges, but it must be there so many.
That's great. Thank you so much for sharing.
My pleasure.
Yeah, so yeah, I want to share that's part of innovation, Monir, that's part of innovation. But the thing is, if you are passionate about it, that will keep you going. And if you really understand the problem, that will keep you going, that there is a problem to be solved. And so that's great. I admire you for even identifying a potential solution is already a big success as far as I'm concerned, looking at the problem. So congratulations.
Oh,
You
thank
have
you.
done a lot. You already have done a lot.
Yeah, I started working on that in 2016. So from 2016, I'm working on the same topic. And I feel myself still motivated as I was in 2016. Yeah, probably the challenges make you motivated much more, and you always expect getting better in the field. And especially when you meet people like you that can provide valuable guiding based on expertise and experience, that would be really, really helpful for me.
Okay, so we are joined today by Dr. Opal Lehman-Bartsis, who is the Executive Director of Education Abroad at MSU, the Interim Director of MSU's Global Youth Advancement Network, and also the judge, one of the judges of last year's Innovation Challenge. Opal, would you like to share your experiences as a judge from last year, and if you have any tips for new participants?
Sure. Well, thank you very much, Sarah. And I want to start by thanking GARD for this opportunity and for creating this event and creating these chances for individuals to really engage their innovative processes and develop solutions that, as our colleague put it, I think so rightly, to look at things for those who are in the greatest need, who may have the least affordability or the least opportunity to afford those solutions. So it's really important that we support these kinds of efforts, and I'm really pleased to be a part of it. Being a judge last year was really rewarding. It was just fascinating to see all of the submissions and to hear about all of the ideas. Came away from that experience feeling like I wish we could have selected all of them, right? It was really a difficult decision, but I'm so pleased to hear from some of our winners from last year, to hear from them today about what's been going on and how the ideas have been refined and the progress that's being made. And so I guess if I have advice for new participants, it would be to simply follow those models of being very clear about your idea, of grounding it in the need that you have identified, doing the research that you need to do in order to demonstrate that the solution that you're proposing is feasible, but that it will have impact. So I think there's the most important, right? The most important part of it, right, is that when we innovate, if we can innovate for impact, then that makes all the difference. And so the ways that you can elaborate on the potential impact, I think, are going to be very impressive. And to also think about how this is feasible. It's important to dream and to dream big. Sometimes our dreams aren't always quite as practical or feasible as we would want them to be. So if you can think about that aspect of things as well while you put your ideas together and then attempt to articulate them. And I know that in this challenge, you have a very short time to articulate. You've got plenty of time to plan, but when it comes down to it, there'll be just a few minutes to articulate. So I think if you can think of it as sort of an elevator pitch, what would you say to someone if you were in the elevator with them for just a couple of minutes and you wanted to describe something? How would you do that? How would you get to the heart of it? And how would you demonstrate the passion that you obviously have for this idea and do a little bit of convincing? And that's not an easy thing to do in a short amount of time. But I think if you keep that in mind as among your goals, that will be a good thing. And so I think that's mainly what I have to share, and just appreciate everyone's interest and energy. And again, it's really exciting to be a part of this.
Thank you, Opal. I know that's going to be such helpful advice for the next round of the Innovation Challenge. So now we did want to open it up to a broader discussion. I'd like to invite any of you, our judge representative, Dr. Lehman Bartzis, or our winners from last year, Dr. Alusilha as well, the members of the planning committee, to discuss your experiences from last year. And do you have strategies or tips for successful innovation? Do you have tips for new participants in this year's challenge? Are there any things that you have learned over the past year and from this experience that you would like to share? So I will open it up for discussion.
Yeah, I just want to again congratulate Dr. Adnani and Sima and Annette. We really appreciate your time, and I'm so impressed with the progress that you have made. And it takes an innovator to move into the direction that you are doing, and it takes courage, it takes stamina. So I just want to congratulate you for that. On the technical side, I want to ask a question for you said about the next step that you want to look at, just a guide that as you move towards making this feasible and attractive to investors, I would encourage you to look at the sensitivity of this one, specificity of your antibodies. And the one thing that is interesting with lateral flow with the antibody method, I would encourage you to check for your antibody supply, because you don't want to go further along into your research and investment only to find out that your antibody supplier cannot supply you with the antibodies, because then that will be another hurdle that you have to face, and then you have to go back to square one in your antibody search, because that is one of the challenges we had, that we had a technology where it was antibody based and everything was moving along well from the research side. But then when we started, not we, but the company that was supposed to license the technology, there's no antibody company was willing to commit that they could provide the volume of the product. So that was in a sense a bummer, because we have to go back to basically the drawing board again.
I can imagine that. Yeah, it's frustrating. Yeah, if it is
Yeah.
about, yeah, if it's
In other words, as you move along, you look at your supply chain,
yes,
like all the parts that you are putting together, that the supply chain is there enough for your customers, so that then you are not bogged down with no supply when you are ready to deploy.
may I ask you, please, when you had this, when you faced this issue, was it just because of the quantity was higher than the capacity of the production of that supplier, or because they have an engagement with other people, so the competition was about getting these antibodies?
Well, there are many factors, right? When you start making those products, you have to make sure that your antibody is consistent, like the quality assessment of that antibody is the same or like close to the same, so that then your product will end up the same result. And that was one of the problems. And the second problem is the volume. They cannot guarantee the volume. And so with that, the company that was supposed to license like just had to withdraw because there is no supply chain. Yeah, so those are just things that you have to think about.
Yeah, thank you so much, actually.
Mhm.
I was not thinking about that. I couldn't see that as a problem because I was thinking probably there are factories that can produce the antibodies, so they are here for producing antibodies. But as you said, probably when we need high amount of these antibodies, it will be challenging to produce them accurately and can ensure reproducibility of the results. Thank you
Because
so
most
much.
of the antibody suppliers are probably doing it for research side,
Exactly.
right? But not for bulk side, you know. I still you mentioned earlier that you're looking for collaboration in terms of making the lateral flow. We have the instruments in our lab to make lateral flow because we used to do lateral flow. You are welcome to collaborate with us, but you have to come though.
It's my pleasure, actually.
Yeah, so we have the instruments for making lateral flow.
That should be great.
So you're welcome to come and visit us here and do some experiments.
And what about the antibodies? Are they available there? Or are there any companies that can provide the antibodies, or we need to order them from abroad, other countries?
You just have, you can check for whether they are available in the US, and most likely they are. Just if you can order and then, you know, ship it or whatever.
Oh.
But I just want to let you know that we have the instruments to do LFA, so you are welcome to.
Yeah.
We welcome your collaboration.
I will come for sure. Yeah, I spent 4 months last year. I spent 4 months in Georgia University. So I was in the faculty exchange program and I was there, but I couldn't find any equipment that could help in that. Yeah, if I still there, I will fly today to meet you.
Yeah, yeah. Just so you know, we have the instruments. We have the equipment.
I will contact you for sure. Thank you so much for offering that.
Yeah, we offer, you're welcome to come.
Pleasure.
I would like to offer Dr. Adnani and Dr. Moholisa and Dr. Sima an opportunity to be part of the GARD. It's free membership, and we would love to have you as part of our team, to be a GARD member. And also, if you could keep us updated, maybe if you can send like a few bullet points of the progress, so that then we can sort of like see how you're progressing. And we would like to see another progress from you if there is a progress next year, so we can increase this winners roundtable, not only to now there's 2, hopefully there will be more next year, and so on and so forth, so that we can organize a good conference just of the winners, right? Over time. So if you can keep us updated, and if you can send Sarah or Luna, James, just a few bullet points of your progress, that will really encourage us, because it will keep us going, that there is impact into the investment last year.
Thank you so much for the invitation. It's my pleasure to accept that.
Oh, thank you. Thank you. So, Munir, if we just need your name and your whatever your institution is, or what you do there,
Yeah.
and then the address, so I will add you to the Algeria group. And also for Enid, you're welcome. And Prudence, if you are willing, let us know. Send us or James the names, and then we can add you to the list.
All
we
right.
just need kind of like an email that says, yeah, we agree to become members, just so we have a record.
Right.
Okay.
Okay.
Thank you.
Yeah.
Thank you.
Thank you, everyone. Thank you to last year's winners for sharing your experiences with us. And thank you all for being here today. As a reminder, this roundtable has been recorded and will be shared for interested participants to view as a resource. We will now conclude the winners roundtable. Thanks for being here.
Thank you so much. My pleasure.
Thank you very much.
Thank you, Sarah.
Thank you,
everyone.
everybody. Thank you, Opal, for
Thank you.
your support, and Luna, Leticia,
Thank you.
James, thank you. And
Thank you,
again,
Opal.
Munir and Enid, Prode, Sima, you're welcome to be a member. You just have to send me an email, or James, whichever.
All right.
All
We'll
right.
do it. Thank
Take
you
care.
so much. Have a good
Thank
day.
you very
Bye.
much.
Bye.
Bye-bye.
Have a great
Thank
day.
you.
Bye-bye.
Bye.